Okay, so now we're going to complete the second problem. Same thing. Um, we're going to make a V, I, and R table. We're going to make a small one here so we have room to work. How many resistors are there? There's 1, there is 2, so we're going to write 1, 2, and then after all the resistors you have, you're going to write a T for the total. Right, so now we're going to get into writing in our given pieces of information. R1 is 12 ohms, R2 is 6 ohms, and VT is 12 volts. That is all of our given information. You have to figure out the total voltages. You have to figure out the currents going through the first resistor, going through the second resistor, the total current, and the total resistance. So, using our set of equation rules here. Using our equation rules here, let me zoom out just a smidge. All right. Okay, I'm gonna hide part of that so you can see this little rules here. Guys, the total voltage is equal everywhere. So if you know the battery, you know that all the voltages are the same. I love putting that one first because no math is needed. If I'm given that, I'm going to fill those in. So I'm highlighting the pieces of information that were not given, all right, but either found through the rule or through a little bit of math. Now, the next thing you can do, you could use the, resistance rule here. All right, 1 over RT. To find RT, you've got to do 1 over 12 plus 1 over 6 is equal to 1 over whatever the decimal or whatever number kicks out. To figure that out, because you had to take the inverse. Or we can start and look at the other rule, which I call the rule of 2. If you know 2 of any in the same row 1, 2, or T, use the triangle to find the missing piece. So if I'm looking for I cover up I. It is V divided by R. I'm going to do that. I'm going to find I1 first. So I1 is V1 over R1. I'm doing 12 over 12. That is 1 amp. I2 is V2 over R2. 12 over 6. 2 amps. So those guys are going to go right here, and we're going to put them in. 1 amp, 2 amp. We found those. All right, excellent. Now, going back to the set of rules. My next one, I can't use the rule of 2, so I could use this to find RT, or I can use this rule, because I have all the currents now, to find the total current. I can just take I1 plus I2, so I'm just going to do that. Now, I like to make my students write this out to show all the work. Okay, if your simple equation, or if they're just asking for one specific thing, it is very, very simple. You're going to take the voltage divided by the resistance to just get a singular piece. Now, to find the total, you need to do both of these, all right, and then solve for that. So the total current, again, was adding them all together. So I1 plus I2, which is just 1 plus 2, or 3 amps. 3 amps. Bam. And now I have 2 in the same row, so now I can use RT instead of having to use this setup here. So RT VT divided by IT. So you're doing 12 divided by 3, which is 4 ohms. And just to show that this also works using this equation here, all right, this should be plus dot, 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 dot. If there's more resistors, if there's less, you don't have to use them all. So 1 over RT, or sometimes written as REQ, you're going to take each resistor value and do this. Okay, you're going to do 1 divided by 12 plus 1 divided by 6 is going to equal a decimal, and you got to take the inverse of that. So 1 divided by 12 plus 1 divided by 6 equals 0.25. So I have to do 1 divided by that answer. I have to do 1 divided by that to get my final answer, and that comes out to be 4 ohms, which matches what we did here. You could have done that, had 4 ohms, and then just done the rule of 2, 12 over 12 to get this, 12 over 6 to get this, 12 over 4 to get this. Either way works. It is a matter of preference. Okay, and then this last problem that you're going to see. Here's the last little bits here, and then now this last one. Set the VIR table up. How many resistors do you see? 1, 2. So we're going to have just 1, 2, and then T. We're going to put in our given pieces of information. What are we given? We are given that 30 volts is over the battery, so that's the T, the total. We're given that R1 is equal to 30 ohms. And now I'm given 3 amps. Now in a series, the current's the same everywhere, but this is a parallel circuit. So what do? Well, if the current was going down through resistor 1, this would be I1. If it was going like this, going down resistor 2, that would be current 2. But if it starts from the battery before it hits this junction point, okay, this is the total. That would be IT. Same thing. If that ammeter was down here and said 3 amps till it comes back to the battery, those are both IT. If it's going down here, it's R1. All right. If it's going down this one, it's R2. So because of its placement, we're going to put this 3 amps here at IT. Okay, so that's all the given pieces of information you have. Now, what do we do, or where do we go from there? So let's zoom out. Let's take a look at our rules. Okay. Again, if you're given the voltage anywhere in a parallel circuit, I like to use this. The voltages are all the same. So that would be the first thing I do in all parallel circuit problems. I'm writing in this 30 volts here. I'm highlighting what was not given, what we had to type in. Now, I have 2 here, I have 2 here. So I'm going to start then what I call using the rule of 2. If you know 2 variables in any row, use Ohm's law triangle to find the missing piece. If I were looking for I, cover that up, it's V divided by R. If I'm looking for R, it's V divided by I, but you have to use the same row. So I1, I is equal to V divided by R, but you have to use the specific V, V1, and specific R, R1. 30 over 30 comes out and gives us 1 amp. So that gets put in. Awesome. Now, you're like, all right, well, what do I do from here? I can find RT right off the rip because I know, right, I have 2, so I can figure that out to solve for R. But let me ask you this. What's good with the I? You're going to have to do this step eventually, so I'm just going to do it right now. If you look at the current rule for a parallel circuit, if you add them all together, you're going to get the total. Well, right now we have the total, and we have one of the missing ones. So to find I2, we're going to take the total minus I1. So I2 is going to equal the total current minus the other currents that you have. In this case, you're just doing 3 minus 1, which is going to equal 2 amps. And finally, we have the rule of two that we can use for these guys. R2 is V divided by I, so V2 divided by I2. 30 divided by 2 is 15 ohms. And then RT is VT over IT, and that will be 30 divided by 3, which is equal to 10 ohms. And again, if you use the resistance equation, well, actually, no, we're not going to. You wouldn't have been able to do that yet because you didn't have the 15. We had to go and work our way around to get that. But that is how you would go about solving for those problems. So you would use the Ohm's law triangle to find the missing pieces that are not given in a VIR table, along with these set of rules.